pH is one of these things that you know something about from middle school and just life, and you know the pH of water is 7, and you know the acids have low pHs, but most people tend to think of pH as like a rating system. And a lot of middle school teachers tend to say, oh, pH goes from 0 to 14. And you start thinking of it almost like a hot or not type scale. It's like, oh, that base is, just horrible. We're going to give it a pH of 14 or something like that, like as if like that gets it kicked off the island. But in fact, pH is just a mathematical translation of H plus concentration into a small number. And you're going to see how it works in just a second here. Let's suppose we had a concentrated acid, okay? Suppose we have a concentrated acid, right? Well, it might, let's put a C in there so it actually spells acid. Concentrated acid, it might have an H plus concentration, right, of 10 molar. That would be pretty much as concentrated as we can make an acid without having problems getting the H plus to dissociate from whatever anion it was bonded to. Suppose we had a concentrated base. Now in this case, it would have taken away about as much H plus ion as it could, and it would leave very little behind. And as it turns out, concentration of H plus might go down as far as like 10 to the negative 15th, okay, molar. But because we're in water, it can never really go down to 0 because water is a supplier of H plus ion. So if we look at this, this is like our effective range. And the trouble is that 10 to the negative 15th is like, has 14 zeros in front of a 1. And this guy has 1 in front of 1, 0. So you've got a range of 10 to the 16th. And that's a lot of zeros. And no one wants to write all those zeros. No one wants to be comparing something in the 1s or 10s place to something in the 10 to the negative 15th place. So instead what we're going to do is we're going to use this pH scale. And we're going to say that pH equals the negative logarithm, right, of the H plus concentration. Now we can also call it the negative log of the hydronium ion concentration, right? So remember that it doesn't matter whether I call it H plus ion or H3O plus, that it works out the same way, right? That it's the same thing in water. So that means that instead, this guy, if we took the negative log of 10, and it would help if I could write, negative log of 10 is just equal to negative 1, right? In this case, the negative log of 10 to the negative 15th is simply 15. And so for practical purposes, we say that our pH scale has a center of 7, and we'll find out why that is in a bit, right? And it goes down for acids, goes down for acids to somewhere like, I don't know, between negative 1 to 0, somewhere down here. And then it goes up for practical purposes to, I don't know, 14 or 15 or so, right? There's no really upper or lower limit. The upper and lower limits are determined by how much acid you can pack into per liter of water, or how much base you can pack into a liter of water, right? So it's not, there's not like a defined beginning and end. However, neutral is defined, and that's defined by water itself. Okay, we're going to see how that works. But the whole idea of a pH scale is simply to take this big range of numbers and make it easier to talk about. Okay, but it's going to have some interesting ramifications when we actually look at how it graphs and things like that. So you need to pay attention to this. But if we take a look at this, this is what the pH scale is, just the negative log of the H plus concentration. Okay, so yay us. Now, if instead we talk about OH minus, we can also talk about pOH. So if pH is the negative log of H plus concentration, right, then pOH is just the negative log of the OH minus concentration. And that's the deal, that P, and a lowercase p in front of something means take the negative log of it. And if you were to look at your calculator, you would find a button on it that says log, right? If you were to look at your calculator like this, it would say log, right? And then right above it, it would say, in little blue writing, say, and maybe it would, maybe we'll even make it blue, so we can mimic reality, right? Then right above it, it would say 10 to the x, okay, in little writing. And the point I'm trying to drive home with this is two things. One is the opposite of log is 10 to the x, and you can remember it from your calculator. That, in other words, that you're like, how am I ever going to remember this relationship? And the answer is your calculator is printing it right in front of you. And so you can say that if right, the negative log of the H plus concentration is equal to the pH, then, right, 10 to the negative pH simply is equal to the H plus concentration. And this is really not a chemistry thing. This is just a math thing. That's what the opposite of log is 10 to the negative, or 10 to the x, right? And so the opposite of negative log is 10 to the negative x. And you can play with this a little bit, and it might be useful to do this and realize that, like, the negative log, right, of 1,000, right, is equal to -3, and that's because 10 to the third is equal to 1,000, right? And so when you take the negative log of it, you're taking the log of 10 to the third, and that gives you -3. And so when you take the negative log of both sides, you get -3. Okay? So when you start playing with this, you start realizing, oh, all we're doing is finding the exponent that we would raise 10 to make some number. Okay? So that's the inverse thing. So that gives us like 4 relationships. And those 4 relationships are going to be pH equals negative. And it's so good that you have to say it twice, I guess. So pH equals negative log H plus, and then 10 to the negative pH equals H plus concentration, and then pOH equals the negative log of the OH minus concentration, and 10 to the negative pOH equals the OH minus concentration. Okay, so we have these 4 relationships. That's all great, but it turns out that there is something more, and that something more has to do with water. And so let's take a look at what happens in water for a second. Okay, so let's get rid of this guy for a sec, and let's talk about water. So if you have water, okay, then you have H2O liquid, and it is in equilibrium, remember equilibrium, with H plus aqueous and OH minus aqueous. Water splits apart, not very much, to make H plus and OH minus. And the K value for this is 10 to the negative 14th. Okay, so that's the K value for this equilibrium. Now, we call it, by the way, KW because we're cool that way. And so KW, right, is equal to 10 to the negative 14th, and it is also equal to the concentration of H plus ion times the concentration of OH minus ion all over 1. And why do we put it over 1? Because water is a pure liquid, and pure liquids don't change in concentration, and so they don't affect the value of K. Okay, so this is, the concentration of H plus times the concentration of OH minus equals 10 to the negative 14th. And this is always true in water. Right, so if we have a solution, this is going to be true. So if we have an acid or a base in solution, that's what is going to happen. Well, it turns out we can take the negative log of both sides, and you're like, why would I ever want to do this? Oh, ye of little faith. Right, if we take the negative log of both sides, right, we get the negative log of 10 to the negative 14th, and that is equal to the negative log of the H plus concentration times the OH minus concentration, right? And we should put that in parentheses so you know you're doing the whole thing. The thing of it is, though, when you have exponents, if I multiply two exponents, I add the exponents, right? Like, in other words, if I have, we can think of, well, let's actually do it this way. I know what we can do. We can say this. We can say that's the negative log, and then we're going to substitute in one of those crazy little functions that we just did. And we're going to call this 10 to the negative pH times 10 to the negative pOH, right? Since we just said that that's what H plus is, we can then substitute that, right? And the funny thing about that is that we know that when you multiply exponents, right, of the same base, that's the same thing as saying negative log of 10 to the negative pH, right, plus negative pOH, right? So we can do something like that. And if we take the negative log of this left-hand side, right, we get 14, right, because negative log 10 to the negative 14th is 14. If we take the negative log of this side, because we now have it as a power of 10, we get negative times negative pH and negative pOH, which makes them positive, pH plus pOH. And this is a crazy useful relationship for us. And this is the fifth equation that we are going to use in this unit. Right, here is this. And this is true because we are in water, right? As long as we've got something in water, this is always true. So if I know the pH, I know the pOH. And this allows us to know either the H plus ion or the OH minus ion or the pH or the pOH and get all the other pieces of information. So we can get all four pieces of information from just one because there's this cool link between pH and pOH. Anyway, that's the whole of the math and that we're going to do in this chunk. And in fact, it's really the whole of the logic of this chunk. And so there's not a lot of chemistry here. It's mostly just practice with mathematics. And you just have to get comfortable with those relationships. Now, we can take something like this, and let's take a look at this guy right here, and let's make it a little bigger so that we can do work here. And you can look at this and see that I've got one of these things, in this case the H plus concentration, right? And from knowing this, I can then go up here and I can take the negative log of 0.5 and get the pH. From this, I can go up here and say 14 minus 0.3 gives me the pOH. And that's because pH plus pOH equals 14. And from knowing this, I can go up here and say, well, 10 to the negative pOH gives me the OH minus concentration. So from just knowing this first piece, I know the other three. Okay. Now we can go in other directions as well. If I started with this, right, I can go up here and say, well, 10 to the negative pH, right, gives me the H plus concentration. And so that would be 10 to the negative 3.4. Now, the one thing that will make your life better, if you punch this into a calculator, you get a number, right? And you might be uncertain of this. But you need to realize that 10 to the negative 3.4 is going to be bigger, right, than 10 to the negative fourth. And it's going to be less than 10 to the negative third, right? That means it's less than 0.001 and greater than 0.0001, right? And so when you punch it in, you're expecting something that's going to be, in scientific notation, it's going to be like blah, blah, blah times 10 to the negative fourth. Okay, so you're going to expect some scientific notation like this, where it's times 10 to the negative fourth power. Oops, and there's Siri. All right, so, and if we punch it in, we get, let's see, 10 to the negative 3.4 gives us 3.98 times 10 to the negative fourth. Okay. Or, right. And I'm actually going to round it. 3.98 times 10 to the negative fourth is the same thing as 4.0 times 10 to the negative fourth, right? Yay, us. And so that's the H plus concentration. It's not very big, right? We can go the other direction. We can go from here to here, and we'd say that pH plus pOH. Actually, let me do it a slightly different way. We'll say that 14 minus the pH is equal to the pOH, right? And so 14 minus 3.4 would give us 10.6, right? So that would be 10.6 would be the pOH, right? And from that, we can get the OH minus concentration. We say 10 to the negative 10.6. Now, if we do that, again, we're going to be between 10 to the negative 11th and 10 to the negative 10th. So I know that my answer is going to be times 10 to the negative 11th. I know that before I even punch it into my calculator. And the reason I keep on saying this is because when you write these things down, you guys have a tendency to forget about scientific notation. Just write the first part of the number down. Or you punch it into your calculator wrong and don't realize you've made a mistake. But if you do this, you should have an idea of what the answer is before you actually punch it into your calculator. So when I punch this into my calculator, negative 10.6, I get 2.5 times 10 to the negative 11th, which is kind of what I predicted, 2.5 times 10 to the negative 11th. Now, the funny thing is, if I take this, not funny, haha, if I take this 2.5 times 10 to the negative 11th and I multiply it by 4 times 10 to the negative fourth, 4 times 2.5 is 10, 10 to the negative fourth times 10 to the negative 11th is 10 to the negative 15th, so I get 10 times 10 to the negative 15th, which is the same thing as 10 to the negative 14th. Now, I would never expect you to check it this way, but you should always find that you get kW back when you multiply H plus times OH minus. So the product of these two numbers should always be 10 to the negative 14th. Anyway, you can see this works, right? I mean, you can just go from any one of these numbers to any one of the other numbers using our set of equations. So if I were to, for example, take this guy and try to go up here I would expect to have 14 minus pOH, right? That would be the way I would calculate it. I would then go up here by saying, okay, I have the pH, so I need 10 to the negative pH gives me the H plus concentration. And then from here, 10 to the negative pOH would give me the OH minus concentration. And so you can always go from one number to the other three. Now, if we look at the actual homework problems, you will find that they have the equations up here at the top, and they look a lot like this chart, but sometimes they're going to be talking about different solutions. And they're going to say, well, what if we have something like H2SO4? And it says, assume that both protons dissociate. Well, if you have H2SO4, they're assuming that you're doing something like this. H2SO4 breaks apart to two H pluses, right, plus SO4 2 minus. Well, if that's true, and you know that this concentration is 0.15 molar, right, then this concentration will end up being 2 times 0.15, right? It'll be twice as big because there are two H pluses for every H2SO4, right? So that would be 0.3 molar. And so you need to realize that in a real situation, like with an actual acid or base, you have to pay attention to how many H pluses or how many OH minuses you actually have in the solution. Other than that, these are just variations on getting you to figure out what the H plus concentration is, what the pH is, what the OH minus concentration, and what the pOH is, and you should be able to do them. One other thing, when we look at this chart, right, if I look at this chart, you may notice that in this case, I have a much bigger H plus concentration than I do an OH minus concentration. And so this is definitely acidic. Right? In other words, that pH is lower than pOH. Right? And we can tell it from two ways. We can tell that this is less than 7, right? So here, this is less than 7. And so it must be acidic. Or you can say, I have more H plus than I have OH minus. And so for acidic, you can say that the pH is less than 7, or you can say that the H plus concentration is greater than the OH minus concentration. Either one of these would imply that it's acidic, right? If we had a base, its pH would be greater than 7, and OH minus would be greater than H plus, right? Because again, water, we assume, is the dividing line. And you might say to yourself, well, what is water doing to the whole pH thing? Well, let me just show you one last thing, and then hopefully that will make sense. And so let's go back to this idea that the H plus concentration times the OH minus concentration has to equal 10 to the negative 14th in water, right? And let's assume for a moment that we have something that is neutral, right? If something is neutral, that would imply that H plus is equal to the OH minus concentration. Well, if that's true, right? If that's true, that would be the same thing as saying, well, it would be the same thing as saying that the H plus concentration squared equals 10 to the negative 14th. So that we could substitute in, we could say H plus times H plus equals 10 to the negative 14th, right? So the H plus concentration equals 10 to the negative 7th, and the pH equals 7. So if we have a neutral solution, the pH has to equal 7 in water, right? Right. Another way of looking at that is for neutral, pH has to equal pOH, right? And if that's true, the only way pH can equal pOH is if pH plus pH equals 14, and that would imply that the pH is equal to 7, right? And the H plus concentration, therefore, would equal 10 to the negative 7th, right? 10 to the negative pH. So this whole neutral pH being 7 thing is not based on some sort of arbitrary rating system. It's based on the fact that it's the square root of Kw, right? And we're doing all our reactions in water. So yay us. Anyway, you should be able to get through the homework problems at this point. I am hopeful that this will have been of some help.